Welcome back to Google Trends Hub, where we dive headfirst into the stories that are shaping our world, faster than ever before. The news cycle is relentless, and staying ahead means knowing what's buzzing right now asterisk. Get ready for a high-octane rundown of the information you absolutely cannot afford to miss. We're bringing you the latest, the greatest, and the most talked-about developments across the entire spectrum of innovation and impact. From groundbreaking shifts in technology to insights that could redefine industries, we've got it all covered. Prepare for a rapid-fire update that will leave you informed and energized. Don't just follow the trends, understand them. Let's get into it. First up, we're tracking a significant pivot in the artificial intelligence landscape. A major player in AI research is strategically shifting its focus, moving from purely theoretical exploration to the tangible, real-world applications that are set to change how we live and work. This isn't just about new algorithms. It's about bringing the power of AI out of the lab and into our hands, tackling the challenges that matter most. The race is on to deploy practical AI solutions, and this development signals a major move in that direction. Next, we're delving into the fascinating paradox of advanced artificial intelligence. Even as AI capabilities soar to new heights, we're seeing some of the most sophisticated tools stumble on fundamental problems. Specifically, we're exploring why high-skilled AI models are finding basic mathematics a significant hurdle. What does this tell us about the current state of AI development, and what are the implications for its future progress? We've got the inside scoop on this intriguing cognitive gap. Then, we're following a key leadership transition that has major implications for the tech world. A prominent director from a leading AI research institution has made a significant move, joining a global technology giant in a crucial new role. This move is already generating buzz, with initial reports offering a glimpse into the strategic direction this individual will be steering. It's a story about talent, strategy, and the ever-evolving landscape of innovation. And finally, we're uncovering the surprising truth about AI's capabilities. While artificial intelligence is proving adept at conquering complex, specialized challenges like advanced Olympiad puzzles, it's encountering unexpected difficulties with fundamental, everyday tasks, specifically school-level mathematics. We'll break down the insights from a leading AI mind on why this disconnect exists and what it means for the future of artificial intelligence. Stick around because you won't want to miss these essential updates. Make sure you're subscribed, hit that notification bell, and let's get you up to speed. AI's new frontier, practical power unleashed. The artificial intelligence sector is witnessing a pivotal shift as leading research labs, including Google's DeepMind, pivot their strategic focus towards the development and deployment of practical AI applications. This move comes amidst escalating competition within the AI industry, compelling organizations to translate cutting-edge research into tangible, real-world solutions that can address immediate challenges and accelerate innovation. The emphasis is moving from purely theoretical advancements to creating AI technologies that can be readily integrated into existing systems and workflows, thereby demonstrating immediate value and impact. Alphabet Inc.'s DeepMind, a powerhouse in AI research, is at the forefront of this strategic realignment. Historically known for its groundbreaking, albeit sometimes abstract, research breakthroughs, DeepMind is now prioritizing projects that offer direct utility and can solve pressing global issues. This includes advancements in areas such as climate change modeling, drug discovery, and complex system optimization. The goal is to bridge the gap between laboratory discoveries and their practical implementation, ensuring that the immense potential of AI is harnessed effectively to benefit society. The intensifying competition in the AI landscape has created an environment where speed to market and demonstrable utility are becoming critical differentiators. Companies are under pressure to not only innovate, but also to prove the efficacy and applicability of their AI solutions in practical scenarios. This has led to a greater emphasis on user-centric design, robust testing, and a more agile approach to research and development. The focus on practical applications means that AI development is becoming more collaborative, involving closer engagement with industry partners, end users, and domain experts to ensure that the solutions developed are relevant and impactful. This shift also reflects a broader trend in technological development, where the ability to integrate complex technologies into everyday life is paramount. For AI, this means developing tools that are not only powerful, but also accessible, reliable, and ethically sound. DeepMind's strategic adjustment is a testament to this evolving paradigm, signaling a commitment to delivering AI solutions that can make a tangible difference in areas ranging from healthcare and education to transportation and environmental sustainability. The journey from complex algorithms to practical impact is a challenging one, but it is increasingly seen as the defining frontier for AI innovation. Audience impact. This strategic pivot is generating significant discussion online, with many expressing optimism about AI's potential to solve real-world problems, while others raise questions about the pace of deployment and ethical considerations. But what happens when these advanced minds encounter the basics? We're about to explore a surprising AI paradox that's got everyone talking. AI's math mystery: why top models stumble on school problems. Even as artificial intelligence continues to achieve remarkable feats in complex domains, a curious paradox has emerged. Many high-skilled AI tools struggle with fundamental mathematics problems typically encountered in school curricula. This discrepancy raises intriguing questions about the nature of AI cognition, the limitations of current training methodologies, and the path forward for developing more versatile and robust artificial intelligence systems. Google DeepMind CEO Demis Hassabis has shed light on this phenomenon, explaining that while AI models can excel at highly specialized tasks, such as mastering intricate games like Go or processing vast amounts of data for scientific research, they often falter when faced with basic arithmetic or algebraic equations. This isn't due to a lack of computational power, but rather a difference in how AI learns and reasons compared to humans. Human learning involves building foundational understanding and applying abstract principles, whereas many current AI models rely heavily on pattern recognition and statistical correlations derived from massive datasets. For instance, an AI might be trained on millions of solved math problems, learning to identify patterns and predict the correct answer for similar problems. However, it may not develop a true conceptual understanding of the underlying mathematical principles. This means that when presented with a slightly novel problem, or one that deviates from its training data in a fundamental way, the AI can fail where a human with a solid grasp of the concepts would succeed. It's akin to memorizing answers without understanding the question. Hassabis and other AI researchers are actively exploring ways to imbue AI with more robust reasoning capabilities, moving beyond mere pattern matching. This involves developing new architectures and training techniques that foster a deeper, more causal understanding of the world, including mathematical relationships. The goal is to create AI systems that can not only process information, but also reason logically, adapt to new situations, and generalize knowledge effectively, much like human experts do. The implications of this are significant. If AI is to be truly transformative across various sectors, it needs to be reliable and capable of handling a wide range of tasks, including those requiring fundamental reasoning. Addressing this math problem is crucial for advancing AI in fields like education, finance, and engineering, where accuracy and logical deduction are paramount. Audience impact. This discussion about AI's mathematical limitations has sparked widespread debate among tech enthusiasts and educators, with many sharing their own experiences and theories on AI's cognitive gaps. From the complexities of AI reasoning to the movements within the AI leadership itself, the tech world is constantly in flux. We're now turning our attention to a major personnel change that's making waves across the industry. Leadership shuffle. DeepMind director moves to Microsoft AI. A significant move within the artificial intelligence leadership landscape has seen Dave Citron, product director at Google DeepMind, transition to Microsoft as a new corporate vice president. This high-profile appointment signals a strategic infusion of talent into Microsoft's AI division and underscores the ongoing competition among tech giants to secure top-tier expertise in the rapidly evolving field of artificial intelligence. Citrin's departure from DeepMind, a pioneer in AI research, and his subsequent arrival at Microsoft are being closely watched for their potential impact on the trajectory of both companies' AI strategies. His role at DeepMind involved overseeing the development and implementation of AI products, suggesting a focus on bringing advanced AI technologies to market. His new position at Microsoft is expected to leverage this experience, likely contributing to the company's efforts to integrate AI across its vast product ecosystem, from cloud services and productivity software to consumer devices. In a candid, Day One report shared on LinkedIn, Citrin expressed his enthusiasm for the new challenge and outlined his initial impressions and priorities. While specific details of his strategic directives are still emerging, his move indicates Microsoft's continued commitment to bolstering its AI capabilities in response to intense market competition. This includes deepening its investment in research, expanding its AI product offerings, and attracting leading talent from across the industry. The tech industry, particularly the AI sector, is characterized by a dynamic environment where talent mobility is common. Key personnel often move between major players, bringing with them valuable knowledge, experience, and strategic insights. Such transitions can lead to significant shifts in competitive dynamics as companies vie for leadership in emerging technologies. Citrin's move is a clear example of this trend, highlighting the strategic importance of acquiring and retaining top AI talent. Microsoft has been aggressively expanding its AI footprint, notably through its significant partnership with OpenAI and the integration of AI features into products like Microsoft 365 Copilot and Azure AI. Citrin's expertise is expected to complement these ongoing efforts, potentially accelerating the delivery of innovative AI solutions to Microsoft's global customer base. The success of these initiatives will be crucial for Microsoft as it navigates the increasingly competitive AI landscape, aiming to solidify its position as a leader in the next wave of technological advancement. Audience impact. Industry analysts are closely scrutinizing this move, anticipating how Citrin's leadership might influence Microsoft's AI product roadmap and its competitive stance against rivals like Google. While leadership changes shape the future, the very nature of AI's capabilities is also undergoing intense examination. We're now examining a fascinating dichotomy in AI's problem-solving prowess. AI's dual nature, Olympiad ace, math novice. In a striking illustration of artificial intelligence's current capabilities and limitations, leading AI models are demonstrating an extraordinary proficiency in tackling highly complex, specialized challenges, such as advanced Olympiad puzzles, while simultaneously struggling with basic mathematical problems typically mastered in early schooling. This dichotomy reveals a critical insight into how AI thinks and learns, prompting deeper discussions about the future development of more generalized and robust artificial intelligence. Demis Hassabis, CEO of Google DeepMind, has articulated this fascinating paradox, explaining that AI's success in areas like competitive programming or advanced scientific research often stems from its ability to process and recognize intricate patterns within vast datasets. These systems are trained on enormous quantities of information, allowing them to identify correlations and predict outcomes with remarkable accuracy in domains where data is abundant and patterns are discernible. For instance, an AI might be trained on countless solved geometry problems, enabling it to recognize visual patterns and apply learned solutions effectively. However, when confronted with fundamental mathematical concepts that require abstract reasoning, logical deduction, or a deep conceptual understanding, skills that underpin basic arithmetic, algebra, or calculus, many AI models falter. This is because their learning process is often more about interpolation and extrapolation within known data distributions rather than genuine comprehension of underlying principles. Unlike human learners who build a foundational understanding of mathematical axioms and theorems, Current AI systems may lack the intuitive grasp of numerical relationships or the ability to apply logical rules in novel, unstructured ways. Hassabis points to the need for AI systems that can develop a more grounded understanding of the world, moving beyond statistical correlations to grasp causal relationships. This involves exploring new AI architectures and training methodologies that emphasize reasoning, common sense, and the ability to generalize knowledge across different domains. The development of reasoning engines or neurosymbolic AI approaches, which combine the pattern recognition strengths of neural networks with the logical processing capabilities of symbolic AI, is seen as a crucial step in bridging this gap. This nuanced understanding of AI's strengths and weaknesses is vital for setting realistic expectations and guiding future research. While AI is undoubtedly a powerful tool for specific, data-intensive tasks, its broader applicability hinges on its capacity to perform tasks requiring more general intelligence and flexible reasoning. The challenge lies in creating AI that not only excels in specialized niches, but also possesses the foundational cognitive abilities to navigate a wider range of intellectual challenges effectively. Audience impact. This ongoing conversation about AI's learning processes is resonating widely, with many users sharing their thoughts on how AI can better bridge the gap between specialized knowledge and fundamental understanding. From the cutting edge of AI capabilities to the strategic shifts within major tech players, the landscape is dynamic. Stay tuned as we wrap up today's essential updates. And that's a wrap on today's essential updates. We saw DeepMind pivot to practical AI applications, explored why advanced AI struggles with basic math, noted a key DeepMind director moving to Microsoft, and uncovered AI's surprising math versus puzzle paradox. Don't miss out on what's next. Hit that like button, subscribe to Google Trends Hub, ring the notification bell, and join the conversation in the comments below. Follow us on all social platforms for more.